Right angle triangles then, solve this triangle. We know the angles add up to 180, so the easiest thing to get is this angle here. This is 90, so these two must add up to 90, so this must be 50 degrees. Now, we know this side, so we can use SOHCAHTOA, can't we? So let's write it down and see what we've got. As far as this angle is concerned, we've got the sine, cos and the tan. We've got the adjacent. And that's what we got. So we need 2 of any 3. So we can use the tangent to get the opposite, which is this side here. And we can use the cosine to get the hypotenuse. So let's use the tangent then. So tan of 40. Tan 40 degrees is equal to its opposite, which is C, over its adjacent, which is 3. So that tells us what C is. C is equal to 3 tan 40, isn't it? Tap that in. 3 times tan 40. 2.52 to 2 dp. Let's put that down. 2.52, and that was to 2 decimal places. And then we want B, which we can get from the hypotenuse from the cosine. So cosine 40 then is adjacent A, which is 3, over the hypotenuse B. So I'm going to move this up to be there, and at the same time I'm going to then move the thing cos 40 that's now times down to divide. 3 over cos 40 degrees. So let's get B. 3 divided by cos 40. 3.92. And that's to 2 decimal places. So we've got B, 3.92. We've got A. We've got C, which is 2.52 rather. And that's everything, so we've solved the triangle. Okay, other triangles, we use the sine rule. We've got the sine or the cosine rule. Basically, in triangles that aren't 90 degrees, we try the sine rule first. We need 3 of any 4. So this formula, which is here, but this equals this equals this, it's 3 formulas in one. So you can use that version there. You can use this one, or you can use this one here. And you need 3 of any 4, so I've written that in. So 3 of any 4, then let's tick off what we've got. We've got angle A, we've got angle B, so we know sine A, sine B, and we've got side, what have we got? We've got side, let's have a look here, because I think we got a little bit more than that. We've got A equals 4.3 in this problem. 4.3. Okay, so we've got A. So 3 of any 4. There's no choice here. This is the option we've got, haven't we, to get B. So here, we could just write it down for B and move the sign up. So B is equal to A sine B, if we wanted, over sine A, couldn't we? I've just moved that up there to be with the A. Put the numbers in, 4.3. Sine B, 36, over sine A, sine 65. So B is equal to then 4.3 times sine 36 divided by sine 65. 2.79. And that's B. And that was to 2 decimal places. So that was B. Put that in the diagram now. And we can tick off that we've got that one. Okay, now we can get the angle C, of course, because the angles add up to 180. So that's good news, isn't it? So 90 and 11 is 101, so this must be 89, mustn't it? 89 degrees. Oh, hang on. What have we got? 90, 101, so this is 79. Try and get it right now. That's 79 degrees. That's right. Now they add up to 180. So what else do we need? We need angle C. So we've got angle C now, which we've just worked out. So we can use this to find C. So C equals, then using this one now, B sine C, B sine C, move that up to times over sine B. B 2.79. That's in the calculator. That's only 2dp, so we want to keep it more accurate by using the value that's in the calculator. Times sine C, sine 79, divided by sine of B, which is sine 36. So let's work out C then. There's the 2.79 more accurately. Times that by 79, sine of 79 that is, and then divide that by sine of 36. And that's the accurate result, 4.66. 4.66, and that was the 2 decimal places. And that's C. Okay. We could have used this form here, couldn't we, to get C? We wouldn't needed the more accurate version to be kept in the calculator then, because we could have just used the original A and the angle A that was already given. And that would have given a very accurate answer, a precise answer then for C, without worrying about the 2.79 error issue. Okay, that's that one then. Good. So that's the sine rule covered in that example. Now the cosine rule. If the sine rule doesn't work, we use a cosine rule. A squared equals b squared plus c squared minus 2bc cos A. That's the formula. And we just try it, basically, is the essence of it. Then you can rotate the triangle, because A can go to B, B can go to C, and C can go to A. And we get the other two variations on the same theme. So this is the formula we remember, and then we can write down the other two variants. So b squared is c squared plus a squared minus 2ca cos b. But normally what we do is, rather than write c squared plus a squared, we generally write that as a squared plus c squared, because it's easier on the eye. And we write ca, generally we write that as ac. And this is okay. C squared is equal to a squared plus b squared minus 2ab cos c. So I hope you can see the pattern of these formulae, and that's the cosine rule. So you can see if we have all three sides, the only thing that we can then need to find out is the angle. Or if we have two sides and the included angle, like b and c and the angle a, as is here, then we can find the other side opposite. Two sides and the included angle, we can find the side opposite. Two sides in the included angle, we can find the side opposite. Okay? So that's how the cosine works, and we generally use it if we can't use the sine rule. Right, let's have a look at this one. Then we need to solve this triangle. Let's get this out of the way. Okay, so cosine rule. So we've got a, b and c, so let's just use the first one then. A squared, so I'll put it in straight away. 11 squared is 121, is equal to b squared. 10 squared is 100, plus c squared. 8 squared is 64, minus 2 times b times c. b times c is 80, times the cosine of a. This is 160 cos a. I'm going to move that over there, put it here. 160 cos a. So what I've done is I've moved that over there, and it's become, this object's become a plus 160, because that's 160 cos a. 164 is here, these two, minus, and I'm going to move that over 121, which is 43. So that tells us what cos a is, doesn't it? Cosine a is equal to 43 over 160. So that tells us what a is, the angle a. Okay, shift cos 43 over 60, 160. Shift cos 43 divided by 160, 74.4. Okay, 74.4 degrees. So there's A. Okay, so we got the angle A then. Now we can either use the cosine rule again to get B here, these, or we could use the sine rule. Because we're using the cosine rule, I'm just going to use the sine rule again to get B, angle B, because we've got all three sides here. So A is 74.4, we've put that in the picture, so I'm going to scratch this now, and I'm going to use the second version. But we could have used the sine rule, which is slightly easier, but because we're illustrating the cosine rule, I'm going to use that. So B squared is 100, A squared is 64, 121 rather, C squared is 8 squared is 64, minus 2 times AC, 811 or 88, times cosine of B, there we are. This is 176, so 176 cosine B is equal to 185 there, minus 100. So we've moved this over, and it's 176 cos B. We've added these two to get 185, and we've moved the 100 over as well. So cos B then is 85 over 176, which gives the angle B. Shift cos, 85 divided by 176, 61.1 degrees. And that's B. So put that in. And then we need to take them both away. Add these and take them away from 180. So 180 minus bracket, the other ones, 74.4 plus 61.1, close bracket. And we get 44.5. Because the angles add up to 180, don't they? So that's that one done then, good. Now we'll move on to the ambiguous case. So let's have a look at that. So I'm going to scratch the above now and use that room to do this problem. So the ambiguous case, let's see what we've got. We've got a triangle here that's, we're told this information. It's not a right angled triangle, presumably, so we use the sine rule. And we can write A over sine A. Just write it down is the best thing to do. Tick off what we've got. There it is. There's the sine rule. Easy enough to write down. We've got A, we've got B, and we've got angle B, so we know the sine. 3 of any 4, so we have to use that to get sine A. So here, move sine A up to be with B. So I'm going to do a lot in one fell swoop here. I'm going to move the sine B up to be with the A sine B. But the B that's alongside the sine A, I'm going to move it underneath. So you might want to take a few lines to write that. So sine A is equal to then A sine B over B, A 5 sine 40 over B, which is 4. So A equals, now if we did shift sine on that, let's have a look at it. Well, sine A, let's just get sine A first. Equals, so I'm going to move it over here. And it's 5 sine 40, 5 times sine of 40 divided by 4. 0.80348. But if you remember sine A, well, if you remember cast, C-A-S-T, sine is positive here and here. So there's possible 2 solutions here because the angles in a triangle add up to 180, and both of these are less than 180, so it is possible to have a triangle that's like a very big angle, like that, isn't it? So we can have a case where that holds. So this is why it's called the ambiguous case. The shift sign has 2 solutions within the 0 and 180. So let's get the first one and then we can just read off the second one. So just do a shift sign. So shift sign of the ants that we just got, 53.5.